Hello, 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 hello. So we are solving redundant connections LC 684 and let's see how we'll solve it. I know my enthusiasm might seem a little down right now because I'm not streaming for very much as I used to. Like I used to stream like 18 hours, 12 hours a day, and now it's much lower. It's like 2 hours. But Uh, this is how the cycle works, I think. You get energy to do a lot, and then you sometimes chill out, and then you get energy to do a lot. And for me, it is the case. And uh, I make sure that I do at least one, two when I don't have that energy, that motivation. But yeah, it's not, I can't do 20, 30 questions every day. And plus, the questions that I'm doing right now are much tougher on my brain. So it actually is a lot harder for me to do. And that's why it takes more time for me to do these questions. And because I don't know these topics, I am learning these topics. That's why I took like 1 month for my interview. And yeah, so let's prepare. Let's see what's the question. So, undirected graph that is connected and has no cycle. A tree is an undirected graph, okay? You are given a graph that starts as a tree with n nodes labeled from 1 to n, so n minus 1 edges with one additional edge, so n edges. The added edge has two different vertices chosen from 1 to n, okay? And uh, was not an edge that already existed. So, okay, so n edges. The graph is represented as an array edges. Okay. Then an edge that can be removed from. Okay, basically, what we want to do is this 1, 3, 1, 2. If that was the case, then this would have been a graph, would have been a 3. But as we have 3, 2, that is an extra edge, which creates a cycle. So we need to find an edge which is not a bridge edge. So when we add 1, 2, then this is a bridge edge. When we add 1, 3, this is a bridge edge because if we cut this, 3 will be a separate component. But when we add 2, 3, this is not a bridge edge. So we can remove this. I think that is a simple disjoint set union that we can do with path compression. And I think let's discuss how we will solve this. Okay, so I've add 1 and 2. Okay, and to the component. So 2 is added to the 1, so 1 becomes the parent. Now I add 1 and 3, so 3 is added to this. Now I add 2 and 3, and I when I find that both have the same parent, at that point I return the answer. So that is what I plan to do. So I think 1 and 2 works, 2 and 3. Um, so different parents. So parent of one is different parents, different parents. So parent of two is one, parent of three is three. 3 and 4, different parents. 3, 1, 4, 4. And 1 and 4 will have same parent because parent of 4 is equals to 1 and parent of 1 is equals to, or 3 is equals to also 1 is equals to also 1. And at that point we realize, okay, this is the excess edge and we can remove this and give out the answer. Because there is only one excess edge, I don't think there is much to do apart from that. But let's see. Which- Cool. Let's do this. So comma rank. I hope I remember how to make. Now let's initialize parent. Void it init. So yeah, so n will be the size of this. So now let's enter int parent of size n and rank so uh, of size n and all the values are zero at first. Cool. Now, okay. So now find parent and find parent. What will it take? Node. If parent of no equals to node, then return node. Else return parent of node is equals to find parent of cool. I think this is so I can do initialize. I can initialize first. That's nice. I can initialize and now for all of them, for all edges, I do union for auto next union set x dot 0 comma x dot 1. Okay. So how does this return the answer? Okay. Let's try something. Let's write union set and let's see how can we union set. Let's make it Boolean. If not union set, return X, I guess. Math1, comma math1. Let's return anything that is hmm. Now union set bool union set int u comma int v u is equals to find parent of u V is equals to find parent of V, and now if U is equals to V on 0, okay, so in that case it will return 0 when the parent is same. Now if rank of V greater than rank of U, rank of V greater than rank of U, so V will become the parent. The parent of U is equals to V, else if smaller parent of V is equals to U, else equal parent of V is equals to U, and rank of right. So parent of V U plus plus return 1. This should work. I think this should work. Find parent. Yeah, line 12. If parent of node is equals to node. Okay, it starts from 1, I guess. It's one index based. I minus 1. So I think I can just do it here only. I should have asked that as a clarifying question. If it's one index or zero index. So O of n uh, makes sense. This is n times, uh, but ideally it's v plus e, but e into alpha n, um, where alpha is almost constant. It's v plus e, and the space complexity becomes v. Let's see if there's any place. Let's see the editorial. DFS is accepted. How do we do DFS in this? Let's we create yeah. Okay, so time complexity is n square. Union find is much better, I think. Complexity of n, I guess. Inverse Ackermann function. We make up and query the SU union, which take amortize alpha and len outside the scope of learning. Approximately one. Cool. Let's move on. Word ladder. A transformation sequence of word begin word to word end word using dictionary word list is a sequence of word begin word S1, S2. Every adjacent pair of the word differs by a single letter. Every I. Okay. Shortest transformation. H will be hot. Ah, it to hot to dot. Okay, every adjacent pair difference. Cool. Okay, cool. So I can build a graph. Hot to dot will take one step. Okay. And dot to dog will take two steps. So it's not possible. Hot dot to dot will take one step. So that it is possible actually. Okay. Do I build a graph from all the members to all others? Like, do I do this n square operation? I think I can do this n square operation. Like for hot, I check if dot is one, it is. So it works out. Then, so for that, I think I should just sort it, I guess. So if I sort this, let's say word list, begin. Yeah, no wrong answer. Cog, dog. Okay. This will be the sequence. Okay. Now, in this sorted form, could I have this dog? I could have dog in T and dof also, let's say, which both are one. Okay. Let's do this afterwards. Now I'll take a break. I'll